Welcome back, students. Due to some technical problem of the recording app, the previous lectures were blurred or these were not clear, so that I am going to teach you the last topic once again, and the topic is synthetic drugs and dyes for your sake of convenience. In previous lecture, we had seen the introductory part of the synthetic drugs. Then we had seen the characteristics of an ideal drug, and then we had also seen the classification of the drugs. Now we are going to synthesize some of the synthetic drugs, and also we are going to see the uses of the drug. And the first one is aspirin. Firstly, we will see the synthesis of aspirin. Look at the reaction. In this reaction, the starting material is salicylic acid and acetic anhydride, while the product is aspirin, that is acetyl salicylic acid. The catalyst used is an acid, that is orthophosphoric acid. In this reaction, we are directly using the salicylic acid, but we may start from phenol. So when phenol undergoes carboxylation, then it gives salicylic acid. This salicylic acid, on reaction with acetic anhydride or acetyl chloride in presence of orthophosphoric acid, gives to you acetyl salicylic acid, that is aspirin. In this reaction, what is happening? There is just a substitution of proton from the oxygen of phenolic group, and there is addition of new acetyl group. So this is an acylation reaction, and it gives aspirin in good yield. Then the next is the uses of aspirin. आता हा aspirin नेमका आपण कुठल्या गोष्टीसाठी वापरतो? तर याचे युजेस आहेत. इट इज यूज्ड ॲज अँटीपायरेटिक, म्हणजे हा आपल्याला ताप आल्याच्या नंतर ताप कमी करण्यासाठी अँटीपायरेटिक ड्रग म्हणून वापरला जातो. इट मीन्स इट इज यूज्ड टू लोअर द बॉडी टेम्परेचर or to treat the fever. It is also used as analgesic and anti-inflammatory agent. It means the aspirin is used to cure body pain or headache, backache, any body pain or anything, that is why this is an analgesic. Then this is also used as anti-inflammatory agent. It means if you have inflammation in your body, then this drug can be used as anti-inflammatory agent so that we can be recovered. The next one is paracetamol. This is very useful drug and easily available at the counter, so that if you have headache or body pain, at that time you go to a medical store and ask him for the then how to prepare this paracetamol, so that we have to see the synthesis of paracetamol. In this reaction, what is happening? When phenol undergoes nitration with nitrating mixture, it could be either dilute H2SO4 and NaNO3, or it could be H2SO4 and HNO3. Any one of these same, both are same, so that we have used dilute H2SO4 and sodium nitrate, that is NaNO3. When phenol is nitrated with nitrating mixture, then it gives ortho and para isomers of nitrophenol. It means 2 nitrophenol and 4 nitrophenol are obtained. Now there is one problem. The problem is that the reaction is giving the mixture of ortho and para isomers, and we want just para isomer. So now we have trouble, and this trouble can be overcome by using fractional distillation. To separate these two ortho and para isomers, we can use fractional distillation, and so that we will get pure paranitrophenol. Now this separated paranitrophenol is subjected to reduce with sodium borohydride, lithium aluminum hydride, or iron and HCl, or tin and HCl. Any one of all those 4 reducing agents can be used to reduce the nitro group directly into amino group. It is better to use iron by HCl, iron and HCl, or tin by HCl, because iron and tin HCl do not reduce other groups, so that the paranitrophenol undergoes reduction with a suitable reducing agent to form para-aminophenol. This para-aminophenol undergoes acylation with acetic anhydride or acetyl chloride to form paracetamol. In this manner, we can prepare paracetamol. Although the procedure or the reaction involves multiple steps, but the reactions are simple and the materials are also simple, or you have learnt before this about these materials. So that this is a very simple reaction. Then the next is uses. This drug is also used as antipyretic, analgesic and anti-inflammatory agent, similar to that of aspirin. But the aspirin was older drug, the paracetamol is new. The aspirin has more side effects as compared to that of paracetamol, so that the preferred one is paracetamol. The next drug is benzocaine. The next drug is benzocaine. In this we will see firstly the synthesis of benzocaine. In this reaction, when 4-amino-benzoic acid reacts with sulfuric acid, when 4-amino-benzoic acid reacts with ethanol in presence of an acid, that is sulfuric acid, then it gives benzocaine. This is a simple reaction and it has wide applications. This drug has wide applications in the field of medicine. In this reaction, initially what is happening, as you know, sulfuric acid is a strong acid. It releases a proton and that proton attacks on the carbon group of the 4-amino-benzoic acid, and this generates a carbocation. Then there is a loss of H2O molecule, and then there is formation of benzocaine. Then we will see now uses of benzocaine. This benzocaine is used as local anesthetic to the skin, mouth and relieves pain. It also relieves from the itching caused by the insect bites. It means benzocaine is used as local anesthetic. म्हणजे एक भूल देणारं औषध म्हणून आपण या बेंझोकेनचा वापर करू शकतो. जिथं कुठं तुमचा सेन्सिटिव्ह पार्ट असेल, जसं की तोंडाचा आतला भाग असेल किंवा त्वचा असेल, अशा ठिकाणी जर का तुम्हाला एखादी मायनॉर सर्जरी करायची असेल तर त्यावेळेस तुम्हाला हा बेंझोकेन लोकल ॲनेस्थेटिक म्हणून वापरला जातो. त्याच्यानंतर हा ज्या काही दुखापती झालेल्या असतील मोठ्या, त्यांचा जो काय पेन असेल, जे काय दुखणं असेल ते दुखणं कमी करण्यासाठी या बेंझोकेनचा वापर केला जातो. आणि त्याच्यानंतर एखाद्या किड्याने किंवा एखाद्या छोट्याशा इन्सेक्टने जर का तुम्हाला चावा घेतला असेल तर त्यावेळेस ते जी काय खाज सुटते ती खाज कमी करण्यासाठी देखील या बेंझोकेनचा वापर केला जातो. The next drug is sulfanilamide. Firstly, we will see the synthesis of sulfanilamide. In this reaction, what is happening? When when acetanilide is treated with chlorosulfonic acid, then it gives to you Paracetamol sulfonyl chloride. This Paracetamol sulfonyl chloride undergo amination or ammonolysis with ammonia form Paracetamol sulfonamide, which on further hydrolysis or acid hydrolysis gives to you sulfanilamide. Now in this reaction, what is happening? One of the hydrogen atom of acetanilide, which is present at para position of the amide group, has been replaced by sulfonyl group, chlorosulfonyl group, and there is loss of H2SO4, that is sulfuric acid. Then in ammonolysis, ammonia is attacking on the SO2 and it is replacing to the chloride ion or chlorine, and it is forming Paracetamol sulfonamide. Now in the preparation of acetanilide, we have used aniline and acetic anhydride, and this acetanilide was prepared to protect the amine group of the aniline. And in last step, now we want to deprotect the amine group, so that we had carried the hydrolysis, and there is loss of that acetyl group and formation of amino group with the loss of acetic acid, and it was the preparation of sulfanilamide. The sulfanilamide is used as antifungal drug. The sulfanilamide is used as antifungal drug and to treat the itching After looking all the drugs, paracetamol, aspirin, benzocaine and sulfanilamide, all these drugs have been covered in this lecture. We will continue further tomorrow in another lecture remaining drugs. So thank you and best luck.